Hi, guys. All right, so our next science experiment is going to be something called crashing colors. It's an experiment in surface tension. So let me go ahead and present this slideshow for you. Okay, so crashing colors, an experiment in surface tension. All right, so let's go ahead and take a look. So first of all, the first thing we're going to talk about is colors. Um, So we know that we have lots of colors in this world. There's millions and millions and millions of different shades of different colors and stuff. But every color that you see in the world is made up of three primary colors. And those primary colors are blue, yellow, and red. So they are primary, they're first, they're most important, and they can be created to create secondary colors, and then those secondary colors can be created to make they call tertiary colors, and then of course every shade after that is just simply just another combination or different degrees of those three main colors. So your primary color mixtures are going to be this. So you have your blue plus yellow, and that's going to equal green. You have your red plus blue, and that's going to equal purple. And then yellow plus red is going to equal orange. Okay, so that's how we create green, purple, and orange, and then different shades from there. Okay, so we're going to make a prediction today. The experiment that we're going to conduct has to do with not just mixing colors, but has to do something called surface tension and what's going to happen to the food coloring when we change the surface tension. So our prediction is what will happen to the colors when you add the dish soap. All right, and we are going to be utilizing three materials: milk, food coloring, and dish soap. All right, so what are we going to need? Well, this is what we're going to need. We're going to need a plate or a pie tin that is at least 8 inches in diameter with smooth bottom, and we'll get that in lab. We're going to use whole milk. Whole milk works a lot better for this experiment than any other kind of milk like Scamarilla fat. We are going to use our liquid food coloring, our red, blue, and yellow, so our primary colors. And then we're going to use liquid dish detergent. Okay. And we're going to use Q-tips, and that's going. And as you can see, the picture up here at the top right here, you can kind of see what we're going to be trying to achieve. Okay. All right. Oops. Clear screen. Go back. Okay. Just learn how to use these new tools on screencasting. All right. So how are we going to do this? So these are the directions that we are going to follow when we do the experiment. Okay. And that's what we're going to do is we're going to fill the plate or the pie tin with whole milk, but not quite to the top. We are going to wait until the milk has stopped moving. So we got to be careful not to bump into it. It has to be like perfectly still for our experiment to work properly. We're going to gently add a few drops of food coloring into the milk around the edges of the plate or the pie tin. We're going to add the blue, the yellow, and the red. Okay, we're not going to mix, so do not mix your food coloring, because then if you mix it, it will not work. The experiment will not work. You have to pour it out and start all over again. Okay, don't mix it. All right, and then what we're going to do is we're going to take the Q-tip and we're going to coat it in our detergent. And then we're going to gently tip the Q-tip into one of the color blobs, and then you're going to draw what you see in your notebook. You're going to draw what you see. Okay, so that's what the experiment's going to look like. You guys will do an Edpuzzle of the experiment to kind of see what the results are going to be, so you have an idea of what's supposed to happen. All right, so some vocabulary that we're going to go over today for this lesson, and the first one is going to be surface tension. So that's the main vocabulary word for this lesson is surface tension. Then we're going to talk about a word called hydrophilic, and then we have another word called hydrophobic, and then another word called surfactants. Okay, surfactants. So these are kind of some hard words, but we'll practice saying them. So you have surface tension. So let's go ahead and use the sticker. So we have surface tension, we have hydrophilic, then we have hydrophobic, then we have surfactants. Okay, and that's what we are going to use. All right, those are our vocabulary terms. All right. So let's first talk about what surface tension is. Okay, so kind of think of when you talk about surface tension, think about the surface of something, what's on top, the top layer. And what surface tension is when the surface, or the top of the surface of the water resists outside forces. So when it resists, it means you're kind of like you're holding it back, you're resisting, okay? Like somebody's trying to come at you and you're like, no, no, stay back, stay back, stay back. Okay, you're resisting them, okay? Stay back. All right, so when the surface of the water resists, so it's basically telling the molecules are saying, stay back, stay back. And it does this because the molecules of the water are kind of sticky, okay? And they're kind of adhesive. And so they're like, no, we don't want you to come any closer. We're sticky and we don't want you any closer. So that's what surface tension is. It's just the molecules are sticky. And so they're resisting the whatever's on top of it from kind of getting past that top layer. And again, we'll talk about, like Ms. Myers, but like what happens when you jump into the water and you go through the surface. Well, we'll talk about that in a later lesson. We'll talk about density. Okay. All right. So the next word we are going to talk about is the word hydrophilic. And the best way to define this word is actually to split the word up into two pieces. It's a Greek word, and it's made up of two Greek words. You might even recognize the first word. You've probably seen that word before. So the first word is hydro. So hydro means water. So those of you who carry around a hydro flask, okay, it's a water flask. It's a bottle for water. Or hydration, okay, means to have water or anything like that. So anytime you see here the word hydro or see the word hydro, it usually has something to do with water. And then the next word is called philic, and that means love. And in the Greek, you don't have to get into whole Greek, words and stuff, but the Greek language has a lot of different words that mean love. In this case, philic is is a word of love that they use for this particular for the definition of this particular word. So it simply means loving water. So basically, it's that the water molecules anything will stick to the water. So there's some materials where the water is like, okay, I like you. You can sit here on top of me for as long as you like. It's okay. You can just sit there. I'm not gonna mix you up or try to make you go away or anything like that. I like you. And so that's what hydrophilic is. They're substances that will stick to the water and they can become best buddies and stuff. Okay. All right. So then food coloring. Okay. So food coloring is hydrophilic. Okay. Actually, food coloring is really just dye in water. And, water is, pretty okay with it. It doesn't mind it. It'll stick to it and they like each other. So it's not something that's going to resist or oh no, don't come near me, Mr. Food Coloring. I don't like you. I'm scared of you. Which is going to bring us actually to the next word. And our next word is hydrophobic. And you probably have heard the other word probably lots of times. So the first word, hydro, we talked about that already. Hydro means water. But I bet you any money that you've probably heard of the second word, phobic. And phobic means fear. So like, oh, I have a phobia of spiders. I am arachnophobic, which means I have a fear of spiders, or I have phobias. I am scared. So that's what phobia is, or that's what phobic is. It means fear. So the word hydrophobic means water fear or fear of water. And then these are materials that will actually repel the water. Okay, will repel the water. So these are materials and molecules that don't like the water and going to try to get away from it. Okay, and they're going to try to escape because it doesn't like it. All right, it's going to move it apart. And the substance that we're going to use that is hydrophobic is dish soap. And you kind of see that, how that works because we use dish soap all the time when we wash dishes, right? And doesn't the dish soap like rinse away when we put water on it? We're scrubbing our dishes and stuff and it's all sudsy and stuff. And as soon as you pour water on it, it just kind of pushes it away and makes it go away and makes it dissolve. Okay, so dish soap is hydrophobic. It doesn't, molecules in soap does not like water. All right, and then our last word is actually going to connect to dish soap, and this word is called surfactants. Okay, and surfactants. And these are hydrophobic substances. So we talked about hydrophobic. These are molecules or substances that are afraid of water. They don't like water. And these surfaces actually will weaken the surface tension. Okay, so the water's like, no, don't do this. Don't come on top of me. I don't like you. And it goes on top, and you're like, no, no. Okay, so that's what a surfactant is. It kind of pushes the water aside, and it's like, no. All right. So for an example, all right, so soap molecules, all right, they will bond with dirt and oil and germs. All right, so they'll stick to those germs, all right, and they'll kind of collect them and everything, and they'll kind of, they'll kind of stick there. And then as soon as you add water, what happens? It washes them away, right? That's why we wash our hands. That's why washing our hands frequently keeps us healthy and clean, because when we wash our hands with soap, that soap, the molecules in the soap, they'll kind of start combining with all the dirt and the oils and the germs and stuff, and then it'll wash it away. And those of us ladies, or those of you who have long hair or really super dry hair, they tell you not to wash your hair too often, because the shampoo and stuff can actually strip your hair of oils, and can dry out your hair. And the same thing like with your skin. They tell you, dermatologists tell you not to use chemicals on your skin that will strip your skin of the natural oils, because then it'll dry out and damage it. And those are surfactants. Right? Okay, so you've done your experiment. All right, so by this time, we've actually done our experiment. So remember, this is for our friends who did not have a chance to do this particular experiment. They were able to do it. So why did the colors mix? So what happened when we did our experiment? Why did the colors mix? Okay. Well, what happened is when we add the detergent to the milk, it pulled the molecules apart and it weakened the surface tension. Okay, so as soon as we added it, like it went, and it like, no, go away from us. And it weakened the surface tension, so it moved everything away from it. Okay, it repelled, the dish soap repelled all of those things. Okay. All right, so the detergent, and the food coloring molecules didn't start to kind of move around because they were all getting all excited with each other. Have you ever something like a bee, comes into a group of people, and like these little bees like kind of come in and into the group, and everybody's like running in different directions. They're like, no, a bee, ah! All right, so it's kind of the same thing. Okay, you add the detergent, and all of a sudden everything gets excited. They're like, no, go away. We don't want anyone near you. Okay, so again, the colors mixed, and we had our primary colors, the red, the yellow, and the blue. And then when they started coming together, they actually started to mix, and then you should have seen green, orange, and purple. So hopefully that kind of worked out for you when you did the experiment. Okay, so that is our experiment in surface tension. I hope you enjoyed it. And all of this is going to kind of build up to when we start doing our last project, which is then going to be about density, and that's going to be our final project. Okay. All right. Well, have a wonderful day, and thanks so much for listening to this Screencastify for the lesson.